Welcome back, sharp minds. Today we are looking at question 21 in our continuous JEE Main Math Marathon. If you have been following along since day 1, give yourself a massive pat on the back because we have officially crossed the 20 question milestone together. If you are new to the channel, you have stumbled into an absolute gold mine. We have an entire dedicated playlist packed with previous 20 conceptual teardowns. I highly recommend taking a quick detour over there if you want to see standard textbook monsters completely collapse using our signature structural shortcuts. Seriously, it is like a cheat code for your brain, and watching them back to back is going to make your mental math feel incredibly fast. Now look at question 21 on your screen. We have a multimodulus equation x modulus x plus 4 plus 3 modulus x plus 2 plus 10 equal to 0. When the average student looks at this, they immediately prepare for a long, tedious, page-turning case split across 3 intervals. They start factoring multiple quadratics, tracing out massive inequality zones, and easily burn 3 to 4 minutes of raw exam time. So let's step back, look at the systematic structure of the problem, and filter out the noise before we touch our scratch pads. So let's think sharp. Hey thinkers, welcome back to Think Sharp Alley, where every turn leads to a smart solution. This is the given equation. Remember, when you deal with linear modulus boundaries like modulus x plus 4 and modulus x plus 2, your critical splitting lines are naturally at x equal to minus 4 and x equal to minus 2. This breaks our real number line into 3 zones. Everything above minus 2, the middle window between minus 4 and minus 2, and the deep negative zone below minus 4. Now, standard textbook practice tells you to expand and solve all 3 entirely. But here is the professional educator's secret. Always use quick quadratic discriminants as validation filter before you invest your energy into long form factoring. So let's look at the first zone, which is case 1, x greater than equal to minus 2. Now when x is greater than equal to minus 2, both absolute value expressions open with a positive sign. Because x is greater than equal to minus 2 means x plus 2 is greater than equal to 0. And if I add 2 on both sides, I'll get x plus 4 is greater than equal to 2, which is greater than equal to 0. So modulus x plus 4 is also equal to x plus 4. So our equation collapses into a standard quadratic. Now pause. Don't look for middle term splits. Let's run a quick discriminant scan, and that gives us 49 minus 64, which is negative 15. Now because your discriminant is strictly below 0, it is mathematically impossible for this curve to cross the x-axis. That means no real roots in this interval. Now let's slide down into our middle zone between minus 4 and minus 2. Here our first modulus stays positive, but our second modulus turns negative. Because x is greater than equal to minus 4, which makes x plus 4 greater than equal to 0. And that is why modulus x plus 4 is equal to x plus 4. But x is less than equal to minus 2. So which makes x plus 2 as less than 0. So modulus of x plus 2 is minus of x plus 2. Now substituting these values into the expression, we get x squared plus x plus 4 equal to 0. So let's run our discriminant filter again. We get negative 15 once more. So look at what just happened. Without doing any heavy exhausting root calculations, we just proved that 2/3 of the entire number line cannot hold a single solution. So 2 full intervals are completely dead on arrival. So this leaves us entirely with our final domain window, the deep negative interval where x is less than minus 4. Now in this zone, both algebraic expression inside the modulus brackets will drop below 0, meaning they must both flip their operational signs where the absolute value bars are stripped away. Now substituting these, we get this, and simplifying this systematically gives us this. Now obviously you can rewrite this equation beautifully by taking minus common, but I've kept it as it is. Now let's test this final discriminant. This gives us 49 plus 16, which equals 65. Now because 65 is positive, we are guaranteed two distinct real values of x. So using our standard quadratic formula, we find that x equal to 7 plus minus root 65 by 2. Now comes the ultimate trap, where most high-scoring students slip up. You cannot just celebrate finding two roots and assume they both work. They must satisfy our case 3 rule. Our values must be strictly less than minus 4 to be valid. So let's run a quick mental estimation. We know the square root of 64 is 8. So the square root of 65 is roughly 8.06. Let's test our two roots with this estimate. First positive root is 7 minus 8.06 by minus 2, which gives us 1.06 by 2, which simplifies to a positive decimal around 0.53. Now is 0.53 less than minus 4? Not even close. So it fails our interval validation completely, so we strike it out. Next, our second root is 7 plus 8.06 by minus 2, which consolidates down to a negative fraction around minus 15.06 by 2, or roughly minus 7.53. Is minus 7.53 less than minus 4? Yes, it fits perfectly inside our designated zone. So after scanning the entire landscape of the real number line, we have exactly one solitary real solution that survives our boundary criteria, which is x equal to minus 7 minus root 65 by 2. But if you see carefully, the problem asks for the number of distinct real solution, which means our total count is exactly 1. So we match that to our choices. Option 2 is your clean absolute winner. Using your discriminant filters early prevents you from chasing ghost roots across complex intervals. If you successfully filtered out those negative discriminant before calculating the final roots, let me know by dropping a thunder in the comment section below. Remember, consistency beats intensity every single day. On this channel, we are solving exactly one high-level JEE question every single day to keep your math fundamentals sharp, focused, and ready for exam pressure. Think of this playlist as your daily revision ritual. Just a few minutes a day to lock in your speed and conceptual understanding. Make sure to hit that subscribe button. Turn on your notification. I'll see you tomorrow for question 22. Keep pushing, stay focused, and always think sharp.